Hello friends, welcome back to our channel. In this video we are going to solve a few more problems on vectors. Let's start with the first problem. Here in this first question we are given a vector is equal to 5 I cap minus 6.5 j cap and b vector is equal to 10 I cap minus 7 j cap. C vector lies in xy plane and c vector is perpendicular to a vector and c vector dot b vector is given as 15. Now, from this given information, we are required to calculate c vector. Now, first of all, let's assume c vector as x I cap plus y j cap. Since it lies in the xy plane, its z component will be going to be 0. Let c vector is equal to x I cap plus y j cap. Now, from the first information we are given that c vector is perpendicular to a vector. This implies that c vector dot a vector is going to be 0. This we have already learned. Now, the dot product of c vector and a vector is going to be 5x minus 6.5y is equal to 0. This is our first equation. And from the second information, c vector dot b vector is equal to 15. We are getting c vector dot b vector is equal to 15. This implies 10x minus 7y. 10x minus 7y is equal to 15. Now we have to solve these two linear equations. I hope all of you can do this. I am writing the answer of this question. Here we are getting x as 39 by 40 and y is equal to 3 upon 4. This is the answer of this question. Therefore, we can write c vector as x I cap, that is 39 upon 40 I cap plus y j cap, which is 3 by 4 j cap. This is the answer of this question. Next we are going to solve question number 2. Here we are given a vector as 3 I cap plus j cap plus k cap and b vector as I cap minus j cap minus k cap. We are required to find the area of the parallelogram whose diagonals are represented by a vector and b vector. Let us first draw the parallelogram. Suppose this is a parallelogram P, Q, R, S. Let's draw the diagonals. We are given that the diagonals are represented by a vector and b vector. Suppose this vector, this SQ vector is a vector. Here SQ vector is equal to a vector and PR vector B vector. Here vector B vector. Then we know the direct formula of finding the area of the parallelogram. If we know the adjacent sides, therefore using these given conditions we have to find PQ vector and PS vector, then we can calculate easily the area vector of the parallelogram. Let us calculate PQ vector first. This PR vector is B vector, therefore this portion, suppose this point is Z, so PZ vector is going to be B vector upon 2. This vector is going to be B vector upon 2. And ZQ vector is going to be A vector upon 2. A vector upon 2. Therefore, by triangle law of addition, we can see that PZ vector plus ZQ vector is going to be PQ vector, this vector. So, one important result we are getting is PQ vector, which is the resultant of PZ vector and ZQ vector. So we can write this vector plus this vector, which is these two vectors. B vector upon 2 plus A vector upon 2. This is one adjacent side. And the next required is PS vector. For finding PS vector, we require this ZS vector. This ZS vector will be opposite to SQ vector. That means it is opposite to A vector. Therefore, it is going to be minus A vector and it is half. So this is minus A vector upon 2. So ZS vector is minus A vector upon 2. Now, by triangle law of addition, we can see PZ vector plus ZS vector is going to be this vector, PS vector. By triangle law of addition, we can easily see. Therefore, PS vector is PZ vector plus ZS vector. Therefore, we can write PS vector is equal to PZ vector, which is B vector upon 2 plus this vector minus A vector upon 2. Now we have got the adjacent sides. Now we can easily find the area of the parallelogram. Now, using geometrical meaning of cross product, we have already seen that the area vector will be given by the cross product of these two vectors, PQ vector and PS vector. Therefore, required area. Here we are asked only the magnitude, so we can take only magnitude, not area vector, as magnitude of the cross product of these two vectors. That means PQ cross PS vector. Here we are getting PQ vector is half of B plus A vector crossed with half of B minus A vector. Now if you simplify this equation, we are getting half of A vector cross B vector magnitude. This simple, we have to just open these two brackets and we will get this answer. This is the answer of this question. Now let's proceed to the third question. Here we are required to find at least one vector which is perpendicular to this given vector A vector, which is equal to 3i cap minus 4j cap plus 7k cap. Now we know that if we have this as A vector, then there are infinite vectors which are perpendicular to this A vector. This vector, this vector, this vector. So there are n number of vectors or infinite vectors perpendicular to A vector. Now we have to find at least one of these perpendicular vectors. Let required vector B vector, which we assume as xi cap plus yj cap plus zk cap. Now we know that if these two vectors are perpendicular vectors, then their dot product or scalar product is going to be 0. Therefore, A vector dot B vector is equal to 0, since A vector is perpendicular to B vector. Therefore, here we are getting 3x minus 4y plus 7z is equal to 0. We are getting this as the only condition. Now let's put x is equal to 1. We can put any values of two variables, that is x, and suppose let us put x and y, and we will get a third variable z. X equal to 1, y is equal to 2. Then let's find what the value of z we are getting. 3 times 1, that is 3, minus 4 times y, which is 2, plus 7 times z is equal to 0. Therefore, z is going to be, that means 4 multiplied by 2 is 8, 3 minus 8 is minus 5. So here we are getting 5 upon 7. So one of the required vectors is, we can write here in this portion, this B vector as x is 1, so I cap, plus y is 2 j cap, plus z is 5 by 7 to 5 by 7 k cap. So one of the required vectors is this. You may have different answers of this question. Now let's solve question number 4. Here we are given this diagram. This is P vector, this is Q vector, and the resultant of P vector and Q vector is R1 vector. Now we are given that if we reverse the direction of P vector, then the resultant gets turned by 90 degree. That means if we reverse this P vector, we will get minus P vector, and the resultant of minus P vector and Q vector, let it be R2 vector. Then we are given that R1 vector is perpendicular to R2 vector, or the angle between R1 and R2 is 90 degree. That means this is the given statement. Then we are required to prove that magnitude of P vector is equal to magnitude of Q vector. Let's start the solution. Now we are given this condition. From here we can directly write R1 vector dot R2 vector is going to be 0. Therefore R1 vector is the resultant of P vector and Q vector, so we can write P vector plus Q vector dot R2 vector is the resultant of Q vector and minus P vector, so we can write Q vector plus minus P vector is equal to 0. So here we can write P vector dot Q vector, P vector dot Q vector minus P vector dot P vector. P vector dot P vector is basically magnitude of P vector ka whole square, plus Q vector dot Q vector is magnitude of Q vector ka whole square minus Q vector dot P vector minus Q vector dot P vector is equal to 0. Now we have learned that the dot product is commutative. Therefore P vector dot Q vector is going to be equal to Q vector dot P vector. So these two terms get cancelled. Therefore we are getting magnitude of P vector ka whole square is equal to magnitude of Q vector ka whole square. Therefore we can write magnitude of P vector is equal to magnitude of Q vector. Hence proved. Next question is question number 5. Here we are given magnitude of B vector is equal to 8 and A vector lies along x-axis. C vector is equal to A vector plus B vector, where C vector lies along y-axis only, and magnitude of C vector is 2 times magnitude of A vector, and we are required to find the magnitude of A vector. Let us assume magnitude of A vector is equal to small a and magnitude of C vector is equal to small c. These two are the assumptions. Now let's use the given information. Therefore we can write A vector as, since it lies only along x-axis, it will be magnitude and the direction is represented by I cap. Its z cap component and k cap components are going to be 0. And C vector lies along y-axis. Therefore we can write C vector is equal to magnitude, which is represented by small c, and it lies along y-axis. Therefore it is going to be z cap. Now we are given this equation. From here we can write B vector is equal to, therefore B vector is equal to C vector minus A vector. Therefore C z cap, C vector minus A vector. So we are getting C z cap minus A I cap. This is B vector, and we are given that magnitude of B vector is equal to 8. Therefore magnitude of B vector is going to be square root of minus A whole square, which is A square, plus C square, and it is given as 8. This is our first equation, and we are also given that magnitude of C vector is equal to 2 times magnitude of A vector. Therefore from here we are getting magnitude of C vector is equal to small c 2 times small a. This is our second equation. Now solving equations 1 and 2, we can easily get the values of small a and small c. That means we can easily get the values of magnitude of C vector and A vector. I hope all of you can do this simplification.